We will move on to the circuit we have, which is the indication circuit. This is a very simple circuit. On top of our cell, you have 5 lamps in the switch gear. One lamp indicates the circuit breaker is off, meaning the circuit breaker is open. And this is a green lamp. The circuit breaker on lamp is red, and you have the earth switch on. This is also red. You have a condition that is white and another condition that is blue. So the circuit here is very simple. I take the DC from a different MCB. If we say the first page had positive and negative, i.e. IND and even IND loss indication, this indication circuit gives you here, you enter here. This is a contact from the circuit breaker's state, and this is a contact from the circuit breaker's state. This is a contact from the earth switch state. And here the earth switch symbol is Q8. All right. And here is a contact from K to K1, from K to K1. These are the ones we studied yesterday, which are the multiplication contacts that also performed multiplication for the breaker state, whether it's rack in or rack out, right? When we said we have 2 limit switches, but the idea of Bashawan's Muhammad al-Hashimi, or I can't remember who asked me, why did you do that? Why didn't you use 6 and 7? I told you that I might need them for other circuits. Where would I get a contact from if I don't have one? So I started using them as auxiliary contacts to take other signals from them. I did something called contact multiplication with them. You'll find that this contact represents the breaker open state, the breaker closed state, the air switch closed state, the breaker test state, and the breaker service state. Of course, you'll find that this connects the DC to this lamp, and this connects the DC to this lamp, and this connects the DC to this lamp, and so on. All right, great. Sometimes you might find the lamps, for example, are on or off. So is the earth switch closed or open? Is the circuit breaker on or off? What's exactly going on with my setup? So it does something else. It comes here and takes a wire from the DC. As you can see, it takes a wire from the DC and brings it down here like this. It passes, of course, a wire from here, and here's a wire from here, and here's a wire from here, and a wire from here, and a wire from here. All right. All of these pass through push buttons, or it's just one push button, but with more than one auxiliary. All right. When you press the push button, the contactor engages. So it directly connects the booster to all the lamps at once. All the lamps are supposed to light up in front of me. And this is what we call a lamp test. It means I'm checking that the lamp is working properly. If I press it and find that a lamp isn't lighting up, it means that the lamp itself is faulty, not because of the breaker. For example, if you come and find the breaker is on or off, you press the lamp test and found that the circuit breaker on lamp lit up. This means you have an issue with the contact itself. Why? Because the contact was supposed to connect, indicating that the breaker on lamp isn't faulty, right? The proof is that when I pressed this button and connected it to a positive, it worked. But if I pressed the lamp test and found that the lamps still didn't light up, what does that mean? It could be that the lamp itself is what's faulty. Is that clear? And finally, of course, you should also have an indicator on the circuit so that if there's an issue, it alerts you to be aware that there's a problem with the circuit. This is so that if you're the maintenance or operations person, you don't come across it unexpectedly. If you want to work on the cable, there's no problem whether it's open or closed, or if the decision to open it was wrong and you should have in the first place, what? And you might have an issue with the DC circuit. What does this mean, engineer? It means you might think the earth switch is closed, but you see it open in front of you. Or you might see the breaker rack out or rack in, but the indication here is missing. Why? Because there's a break in the DC circuit here. So the DC didn't reach its lamps. The earth switch might be open when it should be closed, or closed when it should be open. The breaker might be rack in when it should be rack out, or rack out when it should be rack in, but you can't see it because all the lamps are on. Here the schematic should have a lamp that lights up to confirm that your lamp is functioning correctly, and you should have